Hello again, Hopewell. This is the last type of question we're going to encounter in Chapter 7. This question is not contained in your packet, so maybe take another piece of paper out and write this one down. The directions are a little confusing at first, but let's try to make sense of it. We have a sigma notation, which means we're adding together a partial sum of a series with a formula for the nth term, which is 8n plus 1. Now, I'm saying the nth term because I don't know the location of the term, but any term can be found by using this explicit formula here. And it says it equals 636. Now, this term does not equal 636. So what does 636 represents? It represents the partial sum of the series. It then asks us how many terms were added. We don't know how many terms there are. We would be able to tell if this were a number. If this were the number like 17, we would take 17 and minus 1 and add 1 back, and there would be 17 terms. So we need to find the value of n. In order for us to do this, we have to first determine if this is arithmetic or a geometric series. Based on the formula just alone, it looks like it's an arithmetic series with a common difference of 8. So I'm going to write down my formula for an arithmetic partial sum. The number of terms divided by 2 times the quantity of the value of the first term in your series plus the last term in your series. If we knew what the value of the last term in the series was, we would be able to find n by plugging it into the explicit formula for an arithmetic sequence, but we don't. Here's what we do want to find. We want to find a value of n. In order to use this formula to find n, we need to know the first term, the last term in the series, and the sum of those terms. What we do know is our sum is 636. If we knew the value of n, we wouldn't be solving this question, so that's going to be the variable we solve for. What is the very first term in the series? Plug in the value underneath your sigma into your formula and generate that first term. 8 times 1 plus 1 means the very first term in the series is a 9. Do we know the last term in the series? We do not. Since we don't know the last term in the series, what we can do is symbolically represent it by this right here. 8i plus 1 for the value of n. What we're going to do is we're going to plug the value of n in here, and that's going to represent our last term, 8n plus 1. So together, this combination of two terms represents the nth term. Combine some like terms and let's simplify. 9 and 1 make 10. 10 plus 8n. And let's simplify again. 636 equals. Instead of distributing, I'm just going to divide each of these terms by 2. So I get a 5 plus 4n. Then I'll distribute this n. 636 equals 5n plus 4n squared. What I notice is the equation we have is quadratic, so we can come up with more than one answer, and I'm not sure if more than one answer will make sense in this case. We won't know unless we try. We could try to factor it or use a quadratic formula only if this equation is in standard form. I'm going to go ahead and bring all of my terms to the right, because I always want my leading coefficient to be positive. So the two terms on the right, they don't change their signs, but the term on the left, when I bring it over, will change its sign. Let's use our quadratic formula. N equals the opposite of b plus or minus the square root of b squared minus 4ac. So what's 5 squared minus 4 times a negative 636? Why, of course, that's 10,201. All divided by 2 times a, which is 8. Let's evaluate this formula twice. First, let's use a plus. Negative 5, so n equals negative 5 plus the square root of 10201 is 101 divided by 8. Add the numerator together first and then divide by 8. You get n equals 12. Next, let's evaluate this for the minus. The minus value would be negative 5 minus 101, negative 106 divided by 8. Negative 106 divided by 8 is negative 53 divided by 4. Now, ask yourself this question. Which of these could be the number of terms that we added together, the number of how many terms we added together? Does 12 make sense? Did we add 12 terms together? Or did we add negative 53 over 4 terms? The number of terms can only be an integer that's positive. And since this is neither positive nor an integer, this is an extraneous solution. The answer is 12. We added 12 terms together to make this sum of 636. I hope this helps. This concludes the e-learning for day 4. Go on to your homework and good luck.